Timing gear. It sounds complicated, right? Not at all. It's actually very, very simple, and today I'll take you from the basics to a much deeper understanding of the engine's timing system. Now, so far we've assembled the crankshaft, the two camshafts and the valves. We also installed the oil pump and the water pump, which means we're ready to get the camshafts, the crankshaft, the pistons and the valves working in a sweet, sweet harmony. That's the job of the timing gear. Now this is all the timing gear for this engine, and it's a very typical simple setup for an overhead cam engine. These parts that link the crankshaft and the camshaft are collectively called the timing gear or the timing set. Now, what we're doing when we install the timing gear is synchronizing the piston and the valves for the 4-stroke cycle. The camshafts control the valve positions, and we need those valves to open and close at the right moments as the engine turns. All cars use a mechanical linkage like this for their valve timing. Ignition timing, on the other hand, is all done electronically on modern cars, although historically ignition was also controlled mechanically. An engine will use a belt, a chain or gears for this linkage, but the principles are all the same. The timing gear will always consist of a pulley or a gear that fits onto the crankshaft and one for each of the camshafts. This is a belt-driven system, so a belt runs around those gears, and we have a couple of wheels called idlers which guide it along a compact route on the engine. One of those wheels is a tensioner that can be adjusted to keep that belt nice and taut so that it doesn't slip or jump a tooth. As we said, this is a belt-driven system. Now take a look at this belt. You'll see that it's toothed. We need to be able to set the camshaft and the crankshaft in position relative to each other and keep them locked together permanently. And that's why we need this toothed belt which fits onto or into the grooves on these timing pulleys. Now, belt-driven systems are the most common, particularly for smaller everyday engines like this, where the camshafts are up top above the valves, otherwise known as an overhead cam layout. The timing belt is made of synthetic rubber, and it wears and stretches and needs to be replaced at specific mileages. If the timing belt breaks, then the consequences are really going to depend on luck and the design of the engine. Now, we talked before about interference and non-interference engines when we installed the valves, and it's when the timing belt breaks that your wallet will feel the difference. To recap, an interference engine is one where a fully open valve would overlap with the piston at the top of its stroke. Now, during normal running, this won't happen, but if the timing belt snaps, then the valves stop moving, but the pistons will keep going, and with an interference engine, there's a very high chance that the piston will hit the valves, bending and making a very expensive top-end rebuild necessary. A non-interference engine has no risk of the pistons hitting the valves, so a broken timing belt can simply be replaced and the engine will run again. And you might be asking why anyone would make an interference engine. But higher opening valves and high compression leads to a more efficient engine. And timing belts break incredibly rarely within their service life. It's only when replacement is ignored or it's not changed at the right interval that there's a risk of breakage. And while the belt itself is cheap, there's often quite a bit of labour involved in stripping off the parts and getting access to replace it. Also, you'll see we're about to bury the water pump under this timing gear, so don't forget it makes total sense to replace the water pump at the same time as the belt. Now, another type of timing gear that you'll come across uses a metal timing chain instead of a belt, kind of like a bicycle chain, and instead of toothed pulleys, there are gears. Timing chains are stronger and they're intended to last the lifetime of the engine without replacement, but they are definitely noisier. And for a long chain reaching up and around an overhead cam engine like this, it would require a more complicated tension system than this simple tensioner idler. Now, you'll find timing chains on bigger engines, particularly overhead valve engines, where there's a much smaller distance between the crankshaft and the camshaft. V-shaped engines, 4x4s, those sort of engines often use a timing chain. And slightly less common, or quite a lot less common in fact. You'll find gear-driven timing systems where a series of gears link the crankshaft to the camshaft without any chain or a belt. That's the strongest of all the systems. It's also the most expensive and the noisiest. And again, you'll find that sort of system on a performance engine or on large commercial engines where noise isn't really an issue anyway. And sometimes people actively choose a gear set for the whining noise that it makes. Now, with an engine like the small block Chevy, you can choose from all three types of timing set depending on what you're doing, or what your requirements are, how noisy you want your engine, what sort of performance you want to get out of it. In terms of engine performance, there's really no difference between those types of timing sets. One thing that is worth noting is to do with transmitting vibration or harmonics from the crankshaft up into the valve gear. We'll talk more about that when we get to the harmonic balancer, but for now, just know that the crankshaft doesn't have a perfectly smooth motion. It's being hammered around, which inevitably causes vibration. And a timing belt will tend to dampen these harmonics and transmit them less up to the camshafts. A gear-driven set will do nothing to dampen them, and so the valve gear is going to have a rougher time. And a chain sits right in the middle there. But for most of us, we're going to be working with the timing gear that the manufacturer chose. And for typical modern cars, that's likely a timing belt, which is also called a cam belt in British English, which is the correct English. Right, I've put this on temporarily to talk through the system. I'm going to pull it off now and let's get this installed and actually set up our valve timing. Now first, we need to add a couple of simple parts. A simple housing for the thermostat that extends out towards the front of the engine, and a metal plate that forms the back of an enclosure for the timing gear to prevent any debris getting in. Now, with those installed, we're ready to get the timing set up. And the first and the easiest part of the timing gear is to get things moving at the correct speed. Now, see how the crankshaft pulley is smaller, exactly half the size of the camshaft gears. That's because the camshaft turns once during the 4-stroke cycle and the crankshaft turns twice. So any timing set will maintain that ratio so that the camshaft is moving at exactly half the speed of the crankshaft. Now, the critical thing about timing is to make sure that when we install the belt and we link these pulleys together, that we set them in the correct position relative to each other. And the manufacturer will have provided timing marks and instructions for how to set up the timing. And doing this, it's not difficult, but you do need to follow those instructions, because if we're wrong by a tooth, then it's going to cause poor running. And if we're wrong by considerably more than a tooth, then it could cause engine damage. But from this point onwards, what we do is specific to this engine. So just remember that your engine may be similar, but you still need to get the specific timing procedure. Now first off, we need to get our camshafts into position. And remember how the camshaft is pushing down on the valve springs. Well, those springs are pushing back onto the camshaft. And when you turn the camshaft with a wrench, you'll find that it's not an even movement. Every quarter turn, there's a natural resting position, and between those positions, the camshaft wants to be pushed slightly by the springs which are acting on the things. So the manufacturer will have found a resting position for us. And on this engine, it's marked with these spigots here on the shafts. We need to orient both of those vertically upwards. So we can use a wrench on, there's a hexagon shaped area on the crankshaft that we can use to rotate the crankshaft around until we get into that vertical position. So this is a resting position where the springs aren't trying to push the camshafts in either direction. Now the pulleys are interchangeable. We just need to locate them onto crankshafts. The intake pin, or the intake camshaft, the pin here aligns with the I on the pulley, and unsurprisingly on the exhaust camshaft, the pin aligns with the E. Now we can bolt these pulleys on using thread lock and making sure that we hit the correct torque while holding the camshaft. So next up, we'll install the crankshaft pulley, and the pulley is held on with a keyway in the crankshaft, in the nose of the crankshaft there, and a little key which locks it into position on here. So we need to just get this into its position, and this goes on with the taper facing inwards. Just a little squirt of engine oil onto here will make our lives easier. These keys tend to get stuck, particularly if you're reusing one like we are here. So that's on there. We'll put our pulley on, and making sure that we've got the tapered end facing backwards. Just locate that in there, push it back, and there we go. We're in position. Now what you'll see on the oil pump housing here, we've got a small triangular impression which has been moulded in, and at the top of this crankshaft pulley we have a small cutout, semicircular cutout. Those two need to be aligned. Those are our timing marks. So for the crankshaft pulley we align those, and as we've already done, we need to align the marks on our camshaft pulleys. Now there's two marks. Firstly, we need the I and the E at the top here to be just off vertical. We also want the E and the I to be lined up, which they will be, with markings on the seal plate at the back here. Now, this notch indicates that the number 1 piston is at top dead center. I don't remember if we talked about top dead center yet. Top dead center sounds like it should be an action movie. In fact, I'm gonna find my phone and see if it is an action movie, because top dead center, it's too good not to be. Top dead center. The dead center. That's no good. Someone make a top dead center movie, please. Jean-Claude Van Damme. It's got your name all over it. Anyway, top dead center is when the piston is at the very top of its stroke, at the top of the stroke, and the center being the center vertically. Top dead center for an engine, so we've got 4 pistons here, which means that there's 4 different top dead centers for pistons. But the top dead center for an engine, as we set the crankshaft here, is the number 1 cylinder, the number 1 piston, which is the one at the front nearest to the timing gear. So having set this notch indicates to us that the number 1 piston, being this first piston here, is at the top dead center. Now we can install the tensioner. Now, a tensioner is really just a wheel, 3 wheels on a bearing, and it fits onto the water pump here. It pivots on a pin down here, which it fits over, and that allows it to move in and out of the center of the engine, and it's pulled tight by a spring which fits onto another pin in the water pump housing here. Now I need some pliers. I'll just pop this bolt in there to hold it temporarily. There we go. So you can see the tension in this spring pulls the tensioner across, and the belt runs down and around in this direction. So it's going to apply tension to the belt and hold that nice and tight. Now, as we install this temporarily, while we install the belt, I actually want to hold the tension as far open as possible so that we've got some wiggle room to install the belt here. So I should have probably brought a socket across for this. Here we go. Are we in luck? We are in luck. 14 mil. And just temporarily hold that wide open like this. That's the tensioner installed. The idler wheel, which is just like the tensioner, except it doesn't tension. Again, it's a freewheeling bearing, essentially. This just fits on here to the water pump, and we bolt that into position. Now, when you're replacing the timing belt, it would be good practice, and sometimes you'll find in the kit, to replace the tensioners and the idler, because if these bearings seize, then the belt very, very likely to snap very, very quickly. So it's, you know, again, a cheap part, easy to replace, do it at the same time. I'll just tighten that on. Just quickly make sure that all 3 of our pulleys are in the correct position, aligned with the timing marks, and we can run our belt around. Now, running one of these belts around, always a bit of a wrestling match, you versus the engine. What's going to happen is we'll start down here on the crankshaft, we align this on here, and I think you can already see that our crankshaft is loose because it's freshly installed, lubricated, and it runs nice and easily. And what we're going to do is we're going to run this belt up the right side here, and we're going to pull it taut, quite taut to get in there. As soon as I pull on this, it's going to turn the crankshaft around. You see we're out of alignment now on this bottom pulley. So to make life easy for ourselves, what we can do is we lock, as we get around the pulley and it's in the correct position, we want to lock it, starting with this crankshaft pulley. So what I'm going to do is I'll just make sure that we're aligned perfectly, which we are. And now I'm going to install just temporarily this trigger wheel just over the top. Now I know it means that you can't see the belt, and I'm going to put in the crank bolt. The reason I'm doing this is I want to lock the crankshaft to stop it from rotating. So I'll install this crank bolt all the way down, then using this breaker bar, I'll fit this on here and I will cable tie it around the thermostat. You'll be doing this in the car almost certainly, so you can cable tie this to anything. But once this is cable tied here, it won't move around, and that means we can pull on the belt on this side without risk of knocking the crankshaft out of alignment. Now that we've got the crankshaft pulley locked in position, we can route the belt up around the right side and we can pull on it, get some tension on there, because we don't want any slack on the right side of the engine. We want to keep all the slack in the belt over here so that the tensioner, when we loosen this bolt, will take that slack out of the system. So we'll pull this along here, around the idler, in on the exhaust cam, across the top. Now we can lock this in now that this is installed on there. I'm just going to lock that using a bulldog clip to hold the belt against the pulley. And again, as we're getting around, as we're hitting our checkpoints, let's secure ourselves, lock ourselves in so that there's no more play on this side. Now we only need to worry about this side, which is easy enough, and then we work our belt around the tensioner. Ta-da! One timed engine, hopefully. We've got the belt on. Now we can do a quick sanity check here. On this engine we want, let's take this off. So we've got 2 marks on the camshaft pulleys, 2 timing marks just on the very rims here. And we want to have exactly 19 teeth on our belt between those 2 marks. It's difficult as you look at this engine to see exactly are these wheels aligned, but those 19 teeth are going to tell you, do you have the right distance, the right slack between these wheels. So we count these out, there should be 19. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19. 19 teeth, perfect. So we know that this is set right. Now we can remove this cable tie. And the next thing we want to do is just rotate this system around to be sure that after a couple of rotations of the engine, we're still synchronized. Oh, it feels smooth. So that's 1, 2, 3, 4, and we're back. I'm looking at this timing mark down here. Now we're back to where we were, and let's just look at everything and say, does this look aligned? And to me, everything is aligned with the marks. I think we're good. We're ready to tension up this belt now. You can see we've got tension. This is quite tight, this is very slack, this is fairly tight. What we need to do is set the correct tension on the belt. And the way to do this, the manufacturer has given us a nice, simple setup for it. We've got another mark on the oil pump housing, which is the tensioning mark. And we need to align the crankshaft pulley with that tensioning mark. So to do that, we'll turn the crankshaft 660 degrees, that's 360, and that is 660. At this point, the engines of the 4-stroke cycle, the camshafts are pulling on the 2 pulleys here, and you can see it's taken out all the slack in this top of the belt here and on this side, and all the slack in the system is now on the tensioner side. So as we release this bolt, it's going to pull the tensioner into the correct position. We take this off, that will pull across, and there we go. Just give it a little wiggle to make sure it's taken the right thing. You can see that this spring is what sets the tension in the belt. Now we can tighten up this, and the tension in this system is set right. To check the tension in this belt, what we can do is place a straight edge across these top two pulleys, and in the manual it specifies there should be about 1 centimetre of deflection if you apply 10 kilos. So, you know, I have no idea what 10 kilos is with my finger, but a decent amount that you can pull with your finger, and you should see about 1 centimetre there, and we're about right there. So we know the tension on this belt is good and proper. We don't want the tension too tight because it's going to cause excessive wear in the belt, strain on the bearings and whatnot. So ideally, you know, set the tension to the correct level. That is the timing all set up. Now we can install the timing covers that keep this system clean and debris free, and we can refit the water pump pulley. Okay, so that is the valve timing all set up on this engine. Timing gear, nothing really to be afraid of. Take your time, follow the manual. This is definitely one of those cases where you can't freestyle, you've got to follow the instructions. But it's not that difficult, it's not technically difficult either. So take your time, enjoy yourselves.